very good. Just go ahead.
Okay. Right. Right, so Nate Foster, who we just heard a lovely talk from, writes to me and says, can you do a session overview? The idea of a session overview is to give people the common background for that session so that they have a better background for understanding everything. I said, okay, I'll do it. What session do I have? Medley. So what am I going to do? Well, one thing that all of these papers do have in common is examples. So the common background I want to pull out to you is examples and the importance of examples. So here's, how many people know about awk? So awk, oh, quite a few of you, great. So for those of you who don't know, awk is what preceded Perl. It was called awk because it was designed by Alfred Aho, Brian Kernighan, and Peter Weinberger. They didn't put the names in the right order as authors. And as you can see in this abstract, 1, 2, 3 very concrete examples. So, brilliant. How do you introduce awk? You just give 3 complete example programs and show how much you can do with a one-liner. So I think this is something we should all aspire to. Can we put an example into our abstract? Here's something from Jeff Ullman, another well-known author in our field. So there's this book by Knuth, Larrabee, and Roberts. I think it's almost 20 years old now. But Knuth gave a class on how to write. And by the way, if you liked anything ever that I wrote, that's because Knuth, when he taught data structures, had 1 week on here's how to do technical writing. And I was fortunate enough to take that class. So here's what Jeff Ullman said as he came as a guest lecturer to that class. So these are the notes. Jeff never saw a book with too many examples. Use lots. Even a very simple example will get 3/4 of an idea across. Right? You really want to see the example first and then the formal definition, not the other way around. Examples first. A page or 2 later, you can refine it with a complex example that illustrates all the grubbies. Right? So the point is, well, let's go on. But finding good examples, examples that illustrate all and only the points you are concerned with, is not easy. Jeff has no recipe. You must be prepared to spend a lot of time on it. So for each example you do, you have to think, what is the point I want to get across? And then think of the example, because I want to show some particular feature. I've gotten this nice example. Okay, I've got my example. Oh, wait, the feature I want to talk about isn't illustrated in that example. And then I have to come up with another one. So let's go through these papers. Guided equality saturation. So they give a very nice example in the introduction. They say, we want to automatically be able to prove something like this. A inverse inverse, well, that's the same as A inverse inverse times 1. That's the same as A inverse inverse times A inverse times A. And then, right, we can use associativity to put the A inverse inverse with A inverse. Those are inverse, so you get 1 times A, which is just A. So this proves that A inverse inverse is the same as A. It's a standard textbook proof, and all the systems like EGG that do equality saturation can't really find this. So they do a twist on equality saturation to show this, and then they give an example, a very nice example of equality saturation, E-graphs, to show you start with this structure, and then you keep adding in all the equalities you can find. And this shows how using a DAG rather than just a tree gives you a very compact representation of all the equalities. It's these, the composition. Right, these squares show things that are known to be equal to each other. So this is a paper on direct manipulation of functional programs. And so the sort of thing they want to do, so the paper does not have a link to a video. So I had to write to the authors and say, can you give me actually a video of the system in use? So here's an example of the system in use. So you draw a little ladder. And notice at one point he's going to pick equidistant. We'll talk about that in a minute. Right, so that last step, you saw he selected equidistant, and all of a sudden these four things became exactly equidistant. And then you get this little piece of code out the end. Now, the video doesn't do such a good job of showing the code, but here's the bunch of code you got out. So the idea is you draw a picture, and it turns into code. And then you can edit the code or the picture as you like. So that's a very important idea. And the cool thing, right, is he has a little language for writing what delta you get between one picture and another and controlling that. So this equidistant thing is this little piece of code here. And the important thing to know is this defold. And they have a little language which includes fold, except over differences. And so that let you run over the list of things in these list of points and then make them all equidistant from each other in the y-axis. Inference of robust reachability constraints. So the idea here is we're doing program fuzzing. So here's an example. Okay, so we're doing program fuzzing to find security errors. Now, program fuzzing to find security errors, I can actually show that, is normally defined as you give me a piece of code, and I'll find out if for any input you give it, you could be in trouble. But often what happens is you, the attacker, have control over some of the inputs, but not over some of the others. So the idea here is to extend fuzzing to these kind of security questions. Is there something where there's something out of my control, and for some values of it, I can find an exploit, but for others I can't. So I'm not guaranteed to find an exploit, but I'm not guaranteed there's no exploit. And then what he does is he abducts the formula saying under what situation do these things not under your control let you do the attack. So here's an example. We have the normal sort of copy thing, except it's got a fast path. So this is copying bytes, but if everything is 32-bit aligned on words, it's word aligned, you use this instead. And the problem is the correct one uses less than, but the incorrect one uses less than or equal. So you're doing one extra thing, you're going into memory you're not supposed to go into. And then what he does is he abducts this formula. And what this formula says basically is, right, those two pointers, source and dest, are indeed bit aligned. Right, so this bit at the end, right, is divisible by 32, so that they're aligned on 32-bit words. One thing I want to point out about this is the paper has lots of nice examples, so figure was there, but to get the actual formula abducted, which is sort of the point of the whole thing, I had to unfortunately go back to the author and say, can you give me this bit of the example? And he very kindly provided it. Sorry, the multiple authors. And finally, we have a distinguished paper, Nominal Recursors as Epi-Recursors by Andrei Popescu. And here what he does is there's a particular kind of theoretical structure, so it's a very theoretical paper, but in fact it's a very concrete paper because he goes through a huge number of different structures, these 9, and for each of them he explains in detail what it is and gives all the laws and so on. So there's a huge number of approaches to these different sorts of things, and the amazing thing he's done in this paper, which I think is why it's distinguished, is he shows, okay, we've got these 9 systems, here are the laws that each of them depend on, and then as he systematized, he said, oh, well, there's this law here, but it's actually implied by all the other laws, so you don't need that law. So you have a huge amount of information encapsulated in this one figure, and then he goes through with concrete examples explaining each of these systems, and then gives some very general theorems saying how they relate. So that's the session. I'm told that I once read a book by a book reviewer, and the book reviewer said, well, this guy wrote to me very angry. He said, whenever you like a book, I go off and read it and I don't like it. And he said, that's fine. That means I'm accurate for you. You can read my reviews and know which books to read and which books not to read. So many people have gotten very excited and said, go to everything in this session. I'm actually going to go to the type session because I was convinced by Nick's presentation. But what I hope I have done is given enough of these to you so that you can decide whether you want to go. And I also hope that I've helped you to focus on how important good examples are. Please write papers with lots of good examples. Thank you very much.